Whenever we have a fraction exponent, this can actually be rewritten as a radical. So anytime whatsoever I have a to the 1/2, I can actually write that as the square root of a. And if I can actually take the square root, I want to take that square root. Or in other words, I want to break it down and see if I can pull out groups of 2. So for instance, right here, I have x to the 1/2. Well, x to the 1/2 is just saying the square root of x. There's nothing else I can do with that example. If I take a look at number 54, this is saying 5 to the 1/2. So this can be rewritten as the square root of 5. There's, again, nothing that I can do with that because the square root of 5 is not a pretty number. It's a really, really ugly decimal. But now let's take a look at number 55. I have 4xy all raised to the 1/2. So I can write this as the big square root of 4xy because all of it has that exponent of 1/2. But I can actually break this down a little bit more. And I'm going to look at each one separately and see if I can. And the one thing that I can break down is 4. Because 4 is a perfect square. That square root of 4 is 2. So that means that I can rewrite this where that 2 is out in front, and then I'm left with the square root of xy, because xy, they don't have anything special going on with them. But 4 was a perfect square root, so I can actually take that square root and take it out of that radical. So this would be my simplified answer. It would be 2 square roots of xy. And if I look at number 56, I can go ahead and distribute take this as a square root. We'll deal with distributing in the next one. So right here, because this is an exponent of 1/2, we're going to go ahead and square root this. So I can rewrite this as the square root of x to the 3rd. Now this can actually be broken down a little bit more. Because this is the square root, we are trying to find groups of 2. Now if I have x to the 3rd, that is saying x times x times x. And if I look at this, there is a group of 2 x's right here. If there is a group of 2 x's, then that means that they can be pulled out in front of that square root. But because I still have 1 x left over, that stays underneath that radical. So this would be rewritten as x square roots of x. Because this right here is one group that pulls out, that one group comes out front. This is not a group, so it stays underneath that radical. So anytime that we're dealing with the square root, we're looking for groups of 2. So let's go ahead and let's take a look at 57. Same idea. We're going to take the square root. We're not going to distribute here just because we're going to practice the square rooting idea. We're going to deal with distributing next one. So right here, because this whole entire parentheses is inside with that radical of 1/2, so I'm going to put this whole entire thing underneath a big square root. So I have the square root of 25 x to the 4th. Now again, we can break this down a little bit more because we know what the square root of 25 is. Square root of 25 is 5. So I know 5 is going to be a part of my answer. But for the x's, we have to think about what does x to the 4th really mean. Well, x to the 4th really means x times x times x times x. And what I am doing is I am trying to find groups of 2. I have one group here and one group here. So I'm pulling 2 groups out. So that means I'm pulling out an x times an x. Now there's nothing else left inside my radical, so I don't have to write the radical anymore. But what I do have to do is I do have to simplify 5x times x down, because 5x times x is 5x squared. So then 5x squared ends up being my answer because we were able to take everything out of that radical. And if we take a look at number 58, same idea. The entire thing is inside parentheses, all raised to that exponent of 1/2, which means it's going to get a big old square root. So if I do a big old square root here, I'd have 9x to the 6th, y to the 8th. Well, again, we can break this down. 9, we know. The square root of 9 is 3. Now, if we think about the x's, x to the 6th is saying x times x times x 6 times. And I am looking for groups of 2. I have a group of 2 here. I have a group of 2 here. And I have a group of 2 here. So I'm pulling out 3 groups here. So that means I'm going to have 3 times x times x times x, because I'm pulling 3 x's out. And then let's look at our y's. Y to the 8th is saying y times y times y 8 times. And I am looking for groups of 2. So I have a group here, group here, group here, and group here. So I have 4 groups that are coming out. So this is saying times y, times y, times y, times y. And again, same thing that happened like number 57, everything was taken out, so there is no more radical. But I can simplify this answer down. I can actually rewrite x times x times x as x to the 3rd, and y times y times y times y as y to the 4th. So my answer here is going to be 3x to the 3rd, y to the 4th. Now let's go back to the ones that I said before on the the division one, the number 6, how I said that we were going to come back to these guys because they can actually be reduced. We'll see how the ones that I starred, number 41 and 42, we can reduce these because they have those radicals. So let's take a look at number 41. See how on top it has x to the 1/2? Well, that x to the 1/2 can be written as the square roots of x. The bottom is 16 to the 1/4. So I can't do anything just yet with that. That's going to be on the next video. But right now we can reduce this right here on top as x to the 1/2 as being the square roots of x. And number 42 we can reduce whole entirely because the 49 raised to the 1/2 is saying the square root of 49. And then 16 to the 1/2 is saying the square roots of 16. But we can actually figure out what each one of those are. The square root of 49 is 7, and the square root of 16 is 4. So the answer for number 42 is actually 7/4. We'll come back next video, and you'll see the final answer for number 41.